So a lot of times, some of my students would mention that they get very confused by pressure questions, and as a result, they face the pressure when it comes to doing the topic pressure. Hope you all got that. And as a result, today we are going to address one of the concerns when it comes to pressure. So with every video, here are my general tips that you should try to think about when applying any physics question, especially the part about not rushing, because a lot of times I see a lot of students rushing into it. Oh, I know this answer. And then they realize, hey, that's not really the answer. So don't rush. You should try to use the opportunity to apply these tips in doing the question. And here is the question for this video. It looks simple in the sense that there isn't much information. Take your time to read it, to digest it, and let's see if you can work out the solution to it. So now you can pause to work on the question. Give yourself an opportunity to try to work on the question on your own. You can, if you have no idea, how to start or things like that, take a walk around the room, around your house, downstairs, or whatever it takes to get you to start thinking about it. The point is not, if you really have no idea how to work a question, then the point is not to come to a solution of the question. The point would then is to get your brain to start thinking about the question itself, because thinking is the first step. It is always the first step. So instead of just hurrying over to, um, you know, to get to the solution, you can just point to the next part of the video to get the solution. Just take your time to think slowly about it, and you'll find actually you might improve from there. So pause now to work on the question. So here is the answer to the question. Pretty simple, right? If you have gotten this answer and you're pretty sure of how you managed to get to this answer, that's great. Give yourself a pat on the back. Only one pat, no more than one. If you are totally clueless about what's going on, don't worry, because we are about to come to the explanation in the very next slide. Okay, so this is where I go on to the explanation. Let me just have my laser pointer out. So we're going to start with gas X first. Now gases, they exert pressure in all direction. So look at the space inside occupied by gas X. Imagine that the gases are colliding with the walls of the test tube in all direction and colliding with the mercury at the bottom as well. So I represent whatever pressure that is exerted on the mercury as an arrow, and this arrow is going downwards. So moving on to the next one, mercury itself, being a liquid and it has weight, hydrostatic pressure and all of that, that pressure can also be represented by an arrow that is also downwards, due to the effects of gravity. So you have pressure going on here, and this pressure is actually 15 cm of mercury pressure. The next part might be a little bit difficult to understand, is that how come these two items, the gas X and the mercury, is able to be suspended in a test tube that is upside down? Why doesn't it fall out, flow out, and then come crashing onto the ground and all that? The answer is magic. It's physics magic. No, not really. It's science. It's science. It's physics. Basically, we have something what we call atmospheric pressure. So you see all the green arrows going on here. The thing is this, we are all filled with atmospheric pressure. It's happening all around us and it acts in all direction. As a result, it will go through the opening of the test tube and go inside, and it will actually act towards this direction, okay, supporting the mercury and the gas X. So this atmospheric pressure goes into the test tube and sort of pushes them up. Now, do not confuse pressure with forces, even though I just mentioned the word push. That was meant to help you to understand it better, but pressure is not force, even though there's a formula to relate the both of them. Be careful with the words that you are using when it comes to explanation, especially in structured questions. So with that going on, we can actually come out with an equation over here. The pressure of the gas X adding on to the pressure of the mercury would then give you the pressure of the atmospheric air. And as a result, you put all the numbers inside here, you bring the 15 over, and you get 76 minus 15. At this point in time, some of you all might be thinking, hey, how is it that you're able to take 76 minus 15? This is 76 cm Hg, and this 15 is just a 15 cm. It's a length. How do you take something which is a pressure minus of the length to get the answer here? So the thing about cmHg is that you have to understand what the unit means. The unit of cmHg is trying to tell you that a certain height of a mercury column will give you a certain pressure. Okay, this is in relation to the formula pressure equals to H rho G, where the H represents the height. So the H here is in cm, and as a result, if you look back to here, what they're trying to say is that you have 15 cm of mercury giving you a certain pressure, and in this case is 15 cm Hg. So as a result, even though this is the length here, but because we are talking about mercury over there, you can just straight away take the pressure to be 15 cm Hg, and then you can just substitute inside minus the two of them to get the final answer of 61 cm Hg. Now, in case you are still unconvinced that these two, you're still not very sure why these two items can be suspended in a test tube. You think, hey, it must be fake news. Okay, here's an interesting experiment that you can try. You can go to you can get a cup of soft drink at 7-Eleven or at a food court or wherever the place, and take a straw, dip that straw into the drink, and just pull it up. Now you'll find that the water slides out. The water, whatever soft drink that you had, will slide out and flow back into the water. But if you do that again, you just dip it into the liquid, into the soft drink, and you cover the top of the straw with your finger or your thumb, and you take it out. This time round, the liquid stays inside. Why? Why is that so? Is it magic? No. Because when you cover the thumb, you're basically doing this. When you cover your thumb, you're basically covering the end. When you do so, this is like what you see right now on the test tube. Basically, the atmospheric pressure outside cannot act inwards onto the gas X and the mercury. So as a result, the pressure inside here is much lower than the pressure outside, causing whatever contents to be inside here to be suspended. So long as whatever here is not more than 76 cm Hg, they will stay inside as a result. So there you go. Science can be fun. I hope you enjoyed your soft drink. Yeah, you deserve that, so go for it. So now you understand the solution, understand how to get the answer. Go ahead, dare to challenge yourself, take a step further. if we talk about inverted test tubes, what happens if the test tube is not inverted? What would then be the pressure of the gas X? So have fun with this question. Questions, comments, unclear about something? Feel free to email me at the following address. So if you found that the video helped you and you feel that you've made some progress and you want to make more progress, you want to do more, you want to get the grade that you want for physics, so you can come down for my tuition classes. I have them at Bishan and Clementi. You can contact the center managers for more information, or if you are looking for one-to-one, just email me at the previously mentioned email address and we will follow up from there. In the meantime, I will see you in the next video. Have fun in school, enjoy physics, and goodbye.